Okay, so I'd like to tell you a little bit about the work that I've been doing with the data that have been collected by all of our Streamwatch volunteers over the last 30 plus years. And I want to start by telling you sort of how I came into this conversation to start looking at the Streamwatch data and figuring out, well, what can we do with all of these measurements that we've been taking since the early 90s? Because as Mike mentioned earlier, a lot of the value or a lot of our goal here is this early response and monitoring. We have volunteers going out monthly who will notice quickly if anything is amiss in terms of water chemistry or anything like that, so we can respond to that. But in the meantime, we've accumulated all of those measurements over 30 years. So what else could we look at in terms of these long-term patterns? And the initial question that Edie and Marilyn Dietrich had been working on and sort of brought me into the conversation at that point was a very specific question of looking at temperature thresholds for cold water fish that need particular water temperatures to thrive. And so we have sort of temperature thresholds for these fish, trout and others for different parts of the year. And we know that we have water temperature records going back for 30 years. And so they were looking at this question of, well, if we look back in our historical data, how often did temperatures in our various sites exceed these thresholds at certain points of the year? And has that changed over time? Do we see more measurements where the temperatures are too warm for these fish now than we used to in the past? And so Marilyn had a graph that looked like this in a folder, hand drawn, beautiful graph showing, all right, we know these different points of the year where we have these Pennsylvania Department of Environmental Protection sort of thresholds of different points in the year. What is the acceptable temperature or the maximum temperature? So basically what we're going to be looking at here is that anything under the line is good and anything above the line is too hot. And Marilyn had been looking through the data and Edie looking for sites where we had enough data over a long enough period of time to actually answer this question, because the sites come in and out over time as we're able to access new places or lose access to some places, or volunteers join or leave Streamwatch. And so not every site necessarily could answer this question if we're trying to look over a 10-year period or more. But just as an example, this is a sort of recreation of one of the sites that Marilyn and Edie had already looked at. And so this site, one of the Pocono Creek watershed sites. So on this map here, this is the cranberry bog. So we're just up above that. And Marilyn had pulled out, identified this as a site where we had enough data to look at the early, like I think 2009 to 2012 or something to that effect, or I think just 2009 for this example, comparing 2009 to 2019. And what we're seeing here is, so this point, right, is above the line, so it's too hot. This one's under the line, so it's within limits. The blue is 2009, and then the red was 2019, which is when we were starting to look at the data here. And just within that one site, okay, there's more measurements exceeding the threshold than we used to see. And so that was potentially concerning if there's more events where the water's too warm. But we wanted to look at more sites and figure out, is this a general pattern or is it just a characteristic of this one location? And part of the challenge was just identifying sites that we actually had enough data over that time period to ask that question. But we had found 4 different sites within the Pocono Creek watershed that we were focusing on for this question. And pulling those all together, it's the same graph as before, just multiple sites within that watershed now. And again, the blue is, now we're looking at a whole range of 2004 to 2010, and then jumping approximately 10 years later. Across those 4, slightly more events where the water's too warm for these cold water fish than previously, but it's not consistent across locations. And part of that is that it's just a challenge within a very large data set like this, but it's very volunteer driven. And again, some sites we can't access at certain times, or we have a few months where we maybe miss a measurement. It's hard to look at a single site or even a few sites like this and know, is this telling me something about changes over time in our environment, or is this something about we missed a couple numbers here and that's sort of changing the pattern that we're seeing? And so this sort of sent me into a project that I then worked on for a while, just to try to pull all of the data together across all these different sites and make it easier for us to approach questions like this. So I had started by looking at, all right, well, we have all of these different sets of data for every site we have and every watershed within the overall Brodhead watershed that we're looking at. All of these different sites where we're measuring stream quality month after month. And that can be kind of overwhelming to try and look through what turns out to be 15,000 measurements over the last 30 years, just individual times we've gone out and measured everything, temperature, water chemistry, and all of that, and try to figure out which sites have representation for what questions we're interested in. And so I started just by trying to visualize, like, if I just want to be able to see really easily what sites do we have a lot of information for and what sites could help us answer certain questions, I started trying to make images that basically follow this map of when did we make measurements. So basically, if we had taken a measurement in December of 1991, I'll put a dot here. And if we'd taken a measurement in October of 1996, I'll put a dot here. And then I can just see really quickly, do we have a lot of measurements from this site? Can this help me answer a question if I'm trying to compare the early 2000s to today in terms of what's changing in our watershed? So for instance, this is a site that we stopped measuring early in the history of Streamwatch. It would have been a site that was replaced by something else. So I would need to either then combine this with a nearby site or just not use it for this kind of comparison. And so here's an example then of a site that would have come in more recently, or places that are just kind of in and out. But places like this, we have been really consistent about measuring this site in the lower Brodhead for a very long time. This could help us look for broader patterns. And these are just a few examples, and I'm going to show you that there's a lot more, and there's not a lot that we can look at here and say, oh, I understand what's happening in site 330, except to say that this is sort of this initial approach that I've taken so that we have this sort of library of, hey, if I want to quickly figure out which 10 sites can I use to look at this question that I have, it's going to be easier to go to something like this than to try and scroll through all the numbers and figure out, hey, when did we do what in what location? So as I mentioned then, this does turn out to be over 15,000 times that a volunteer has gone out and collected water and measured temperature and measured nitrates and measured phosphates at almost 100 sites since 1991. So these regular measurements of temperature, pH, water chemistry. And as I mentioned earlier, and as Mike had mentioned, this is really valuable for our ongoing monitoring and for rapid response to any anomalies. But now we're back to this other question of what can we learn from the long-term data set? And if we're looking at very specific questions that I still have some work to do on, like the cold water fish thresholds, we're at a point now where I could go back in and figure out, okay, which sites can help me answer that question and which sites will sort of introduce confusion. But for other questions, we are in a position where we could basically just combine everything we've done over the last 30 years and see things like, this isn't going to be a huge surprise, but it's warmer than it used to be. So we've documented changes in air temperature over the last 30 years in our watershed. We've documented changes in water temperature across all the streams we've been monitoring over the last 30 years in our watershed. And so we've seen an increase of about 2 degrees on average. This is summer temperatures in particular. So I have all of this sorted out for any month you'd like or any season you'd like. It's not all here because we could spend hours on it, but I have it. But just as an example, looking at summer temperatures over the last 30 years, there's a lot of variation from location to location for sure, but the trend overall, the places we've been looking is clear. Yeah, Mike? You're muted.
Yeah, 2 degrees, especially Celsius, is well above what you would expect from climate change, which is one way to explain it, but it certainly doesn't explain it adequately. So, and that's really troubling because that could really change the whole biology and health of the stream. Any hypotheses for why our watershed is warming?
So part of that could be noise from changes in which sites we're measuring. And so one thing that we could do is go in and sort of, and I have all this too, if we want to scroll through it, but look site by site, what's actually happening in an individual location. Because if you imagine that a bunch of these are different locations than a bunch of these, because we're changing where we're going over time, some of that could be coming into that pattern. But that I wasn't going to dive too deeply into statistics, but if I control for that, we still do see a trend, which we would expect.
Yeah, that's disturbing. I mean, I'm worried more about runoff from asphalt and parking lot.
Yeah, yeah, absolutely.
Okay.
So one thing I can show you is just dividing that up, and this will maybe also hint at that problem, dividing it up just among the different watersheds. The one thing I want to mention is it seems unlikely that Cherry Creek's actually getting cooler necessarily, but we may well just have different sites here than we were measuring 20 years ago that's driving that pattern. And so again, a lot of the work that I've done to date has been getting everything into a place where we can pull out these different subgroups really, really quickly to try and answer those questions as they come up. Because you're right that that's kind of either a concerning or a suspicious increase. And it's a little harder to see when we separate it out into the 7 different areas. But we are at least substantiating the general increase. Some look more concerning than others, so maybe that's driven by site changes, or maybe there's something going on there. So I had been sort of coming to that question anyway of, we know that different sites were coming in and out over time, and we want to make sure that these long-term patterns are reflecting these true changes over time rather than differences among locations that we were measuring at different times. One thing I'm hoping to do actually is I have at ESU a graduate course in data analysis for the biology students, and I haven't been able to offer it since before we started looking at these data a couple of years ago. I'm hoping though that I'll have that course in the spring, and I may see if some students can poke at this further in the spring, because it's a giant data set and they may as well get some practice on it. So if there's particular questions you'd like to pull out of here, I will certainly throw it in their direction. So the student projects, but also more generally, a lot of the effort to date has just been getting to a point where it's easy to do this kind of question, as opposed to pulling values out of 7 different Excel sheets that each have a separate table for each site. Just it's all in one place, and now we can organize it however we want to ask this kind of question. One other thing I do want to mention though, is that I've focused on, well, for now, temperature measurements, although I'm working on looking at what can we do with nitrates or phosphates, if anything, or maybe we're less looking for like changes over time in that, but maybe looking at, well, just how often did we successfully document that there was an anomaly that we could respond to, or just some questions like that. That can be a little bit more challenging to work with, because there's some variation in if we're recording exact measurements or just is it below a certain threshold, and sort of getting all of that into the same place or into the same format so I can approach it the way we've approached temperature. Is a bit of a project, but that's in the works. But one other thing in addition to those is when you start looking through all these Streamwatch observations over the last 30 years, there's an incredible amount of commentary from Streamwatch volunteers that's just, it really brings all of this to life in a really nice way. where it really reminds you this wasn't just a bunch of chemistry and temperature measurements. This was people who were going out and noticing things about the stream that they were working in. And of course, not every volunteer is going to be writing down all of the same kinds of observations, but if you go through the data set, you get the billion different records of all the birds everybody saw. And slightly less of everything that isn't birds. So at some point there were a few avid birders in there. But animals around the stream, animals in the stream. I was, as a plant ecologist, delighted that at least a couple people were putting the plants in there for me, and what was flowering at different times when they were taking these observations. And people were making really astute notes of things like a comment that Japanese knotweed is becoming a problem in 1999 at Forest Hills Run. It's like, hey, you're not wrong. And so it was nice to see that note in there, or notes on, I seem to have turned my screen off, but that's right. Notes on things like, I noted that garbage was dumped here, abundance of gypsy moths in a particular year, notes on when floodwaters had knocked all the plants over, and things to that effect. And it was just really nice to have that record associated with all the temperature and all the pH and all the other water chemistries, all of the sort of detailed level of paying attention to the environment that all of our volunteers had been doing. That's, I think, to my mind, an equally valuable part of the record, even if it's not something that we could sort of statistically analyze.